Hey there, MSM3. We are starting Unit 5, Systems of Equations, which is one of my favorite lessons in the whole year. So, systems of equations, two or more equations which state relationships that must be true at the same time. A solution to the system is an ordered pair, and that ordered pair has to make both of the equations true. So what you can see here is that I have a pair of equations. I have one in slope-intercept form, y equals mx plus b, or y equals 3/2 x minus 1. And then I have a second one, also in slope-intercept form. So I've got the slope of the first one as 3/2, and the y-intercept of the second one as -1. Oh, sorry, first one. And then I have the slope. See how it's negative x? Remember that means that the slope is -1, and the y-intercept is 4. So when I go to graph those, I'm going to start with the y-intercept of -1, and then a slope of 1, 2, 3 over 2, 1, 2, 3, right 2. And I know it's 1, 2, 3, right 2 because it's positive. It's going up to the right. And that would be the equation, or the graph of the equation for y equals 3x minus 1, 3/2 x minus 1. And then the second one starts at b equals 4 and has a slope of -1. So that's the same as down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Remember, a negative slope goes down to the right. And so when I graph that one, -x plus 4, you can see that the two lines intersect. They have one point in common. That one point is called the solution. It's an ordered pair. You'll notice that the location is 2, 2. So the solution to the system is 2, 2. Now that means if I go back to this equation and I say y equals 3/2 times 2 minus 1, I get y equals 2. And if I substitute x, -2 plus 4, because it was -x, so -2, y equals 2. So when I substitute in x equals 2, in both cases I get y equals 2. So that one ordered pair is a solution for both equations at the same time. Another method for solving system equations is by using substitution. Now, in order to do that, one of the equations has to be a single variable by itself. So this first equation, you'll notice 5m equals n. So anywhere I see the letter n, I know it's worth the same as 5m. So on the second equation here, instead of the letter n, I can substitute that 5m. So 2m plus 3. Now instead of n, it is equal to 5m. It's kind of like in sports. If I take out the quarterback, I'd have to put in a substitute quarterback. So I'm taking out the n, which is equal to 5m. I'm taking out the n 3 times, and in place of it, I'm putting in the 5m. And now I need to simplify the left side. So 2m plus 3 times 5m is 15m. I add those together, 17m equals 51. And it's a single step equation at this point. Divide both sides by 17, and m equals 3. Now, that is one coordinate, or one part of the coordinate, I should say. The m value is 3. I then have to go back up to either of the first two equations. Now, the top one is clearly the simpler one. 5m equals n. I'm going to substitute that 3 in the place of the m. 5 times 3 is 15. So the entire solution is this coordinate, m equals 3 and n equals 15. Because they're in alphabetical order, I can also write it as 3, 15, or you can also say m has to equal 3 when n has to equal 15. That is your solution to this system. It will work in both. Now, we just proved that it works in the second one, right? 5 times 3 equaled 15. So when m was 3, n was 15. We can also check, does 2 times 3 plus 3 times 15, right? This was my m value, this was my n value. Does that actually equal 51? So does 6 plus 45 actually equal 51? And it does. So that equation, the second equation, also works when m equals 3 and n equals 15. All right, the second one that's on here, if you look and you say, okay, well, she said one of the equations had to have a single variable all by itself. This time it's the second one, y equals 2x. So anywhere I see y, I can put 2x in its place. So in the first equation, in this spot for the y, I'm going to put a 2x there instead. So 7x plus 3 times, instead of the y, I'm going to substitute the 2x. So it's just the first equation, 7x, plus 3 times y, plus 3 times, remember y was equal to 2x, and then equals 13, equals 13. So 7x plus 6x, I'm simplifying the left side, and then I'm going to divide both sides by 13, and I'm going to get x equals 1, and then I'm going to replace my marker. So x equals 1. So you're like, okay, she said that's only part, right? That's only one of the letters. So x equals 1, and then I'm going to go back to one of the two equations that was originally there. I'm going to pick the simpler of the two, y equals 2x. Instead of the x, I'm going to substitute the 1, so y has to be 2. So the answer, the solution to the system, x has to equal 1 and y has to equal 2. I can also write that as the coordinate 1, 2. This is my x value, this is my y value. Now, I just proved that it works in that second little short equation, but does it work in the first one? 7 times x is 1, plus 3 times y is 2. Does that actually equal 13? 7 times 1 is 7, 3 times 2 is 6, and 7 plus 6 is 13. So it does work in both equations. And that's the whole point. A solution has to work for both equations. Now, this one, you will notice, is a little bit more complex, I guess you could say, because the first equation, you'll notice, has a variable all by itself, r equals s minus 4. So anywhere I see the letter r, I can substitute the s minus 4. And here's where those parentheses get really important. In the second equation, where you see the r, that's where I'm going to put the s minus 4. That's where I'm going to substitute. So 5 times, in place of the r, I'm going to put s minus 4, and then plus 2s equals 8. The only thing I did was substitute s minus 4 in place of the r. But now I need to use a distributive property, 5 times s and 5 times minus 4, in order to simplify. And I'm still simplifying the left side. I've got 5s plus 2s. So I've got 7s minus 20 equals 8. This is a two-step equation, so I have to add or subtract on both sides. I'm going to add 20. 7s equals 28. Divide both sides by 7. S equals 4. And you're thinking, oh, she told me I have to have 2, right? It's not just 1. I'm not done here. Gotta fix the focus there. Sorry about that. Now I have to go back and say, well, s equals 4. What's the value of the other variable? So r equals s minus 4 was the first equation. So I'm going to say r equals, instead of s, I'm going to plug in the 4. 4 minus 4. So r has to equal 0, which is perfectly fine. Variables are worth 0 all the time. You didn't do anything wrong. So I'm going to say, if r equals 0 and s equals 4, alphabetical order, rs, they come right next to each other. So we could say 0, 4 is our, sorry about that, is our system solution. It is the ordered pair, 0 standing for r, 4 standing for s, that solves both equations. I just proved that it works for r equals s minus 4. I can also check 5 times the r value of 0 plus 2 times the value of s. We said that s was 4, and does it actually equal 8? So 0 plus 8 does in fact equal 8. So that coordinate, r equals 0, s equals 4, that is the solution to our system. Last but not least, what if it's a word problem? You were also using substitution when you were figuring out when Janet and Sarah had saved the same amount of money. So this is a previous scenario, but they've given us the equations again. Y equals 200 plus 30x, and y equals 140 plus 50x. Remember that we set the two equations equal to each other to solve. That was solving a system of equations by using substitution. So anywhere we see the y, we can put 200 plus 30x in place of it. So in the second equation, I can take out the y and put in the 200 plus 30x in its place. So instead of y equals 140 plus 50x, instead of this y, I'm going to put in its place the 200 plus 30x, and then the right side still says plus 140 plus 50x. So all I did was I took out this y and I put the 200 plus 30x in its place from the first equation. So here I am going to subtract 30x on the left, subtract 30x on the right. I'm going to subtract 140 on the right, subtract 140 on the left. It's down to a two-step equation. 60 equals 20x, and divide both sides by 20. And I'm going to get 3 equals x, or x equals 3. Now, the x value stood for months, okay, in the original scenario. So if we just wanted to know how many months would it take for them to have the same amount of money, we would say 3 months. But how much money will they have after 3 months? At 3 months, when they have the same amount, how much is that amount? So I would then go back. I can pick either equation, since it has to work for both of them. Y equals 200 plus 30x, and I'm going to plug in the 3 months. That means she's got $200 plus $30 per month for 3 months. So $200 plus 90. After the 3 months, she's going to have $290. So our solution could be 3, 290. We can also check the other person's. We can also check to see, does 140 plus 50 times 3, does that also give us 290? And it does. After 3 months, both Janet and Sarah will have $290.